Today is Tuesday, April 26th. It's a testing day, state testing day. So for chemistry here today, we're all doing the review that does from the chapter 14 that does not include colligative properties. And we're starting with question 63. This assignment is from Schoology. I don't have it up here right now. You can look it up. You can look it up what it is. I showed it to you yesterday. Okay, question 63 on page 508. Page 508 says, what is the difference between molarity and molality? Molarity is moles per liter, moles of solute per liter of solution. Now remember, your solution is solute and solvent. Now, because with molarity, temperature can affect the volume. If you heat the solution up, the volume will increase slightly. We have to measure all molarities at 25 Celsius in 1 atmosphere, or at least define what they are if it's not this. You don't have that problem with molarity or molality, because with molality, everything is based on grams and kilograms, and weights don't change on the balance as temperature changes. I've showed that to you before. Molality, and I used a small m here, even though it's at the beginning of a sentence. Molality expresses concentration as moles of solute per kilogram of solvent. Molality does not depend upon the temperature of the solution. Next question, 67. According to lab procedure, you stir 25 grams of magnesium chloride, MgCl2, into 550 milliliters of water. What is the percent by mass of MgCl2 in the solution? Well, a milliliter of water has a mass of 1 gram, so you got to do that conversion. So you have, by percent by mass, mass of solute over mass of solution, or mass of solute over mass of solute plus mass of solvent. We have 550 milliliters of water. Water is a solvent. Water has a mass of about 1 gram per milliliter. It's precisely 1 gram per milliliter at some conditions, at a specific set of conditions. So 550 grams of water plus the 25 grams of solute are divided into the 25 grams of solute. In this case, our solute is MgCl2. And when you do that, when you divide 25 by 575, you get 0.043 or 4.3%. Number 68. How many grams of LiCl, lithium chloride, are in 275 grams of a 15% aqueous solution of LiCl? Once again, use your percent by mass equation. You should have it in the back of your lab book by now. It's in the book, it's in your notes, it's in Schoology, it's in the weekly notes. So you put the numbers where they belong. Your 15% is on this side. And 275 grams is here. Now, the one thing I did not show you on this is you have a times 100. Okay? This has already been converted. It was 0.043. It's already been converted to percent. Here you have a times 100, but this side was given as percent. Notice I already did the times 100 and wrote my 15% as 0.15. Okay, and there's 275 grams of solvent. All you've got to do is bring this up here and multiply, and you get 41 grams. Next, we have number 71. Calculate the molarity of a solution that contains 15.7 grams of calcium carbonate in enough water to make 275 milliliters of solution. By the way, this would not happen because calcium carbonate is not soluble enough to get that much dissolved in water under those conditions. I just realized. But we'll play ball. Okay, first, you have to get moles, because I think this question was molarity. Was it molarity? Molarity, which is moles of solute over liters of solution. So we need moles of solute. Calcium carbonate is our solute. We have to convert it to moles. So 15.7 grams of calcium carbonate, and I'm dividing by 100 grams. Remember from the periodic table, calcium is 40 and change. So there's 1 calcium times 40. 1 calcium times 40 is equal to 40. 1 carbon times 12 is equal to 12. 3 oxygen times 16 is 48. You add all that up, and you get 100. Pretty close to. If you use a calculator, you're going to get, and the numbers off the periodic table, you'll get something a little different from this. But 15.7 grams divided by 100 is 0.157 moles calcium carbonate. And then you have to calculate the molarity. So let's put the moles over the liters of solution. 275 milliliters is 0.275 liters. Yes, you're expected to know the metric system and the conversion milliliters to liters. I expected to know that a year ago. So when you divide these two on your calculator, it comes out to 0.571 molar. The next question I think is also molarity. Number 72. What is the volume of 3 molar solution made with 122 grams of lithium fluoride? Again, we're going to have to turn that 122 grams of lithium fluoride to moles. Then we get the moles, we got the volume, we can do the moles per liter, and get the molarity, just like this. You are supposed to know the equations for molality, molarity, and percent by mass. So make sure you're prepared with that. Okay, so 122 grams of lithium fluoride. There are 25.9 grams of lithium fluoride per mole, because lithium is about 19, I think. I mean, fluorine is about 19, and lithium is a little less than 7. So there are a little less than 26. This is supposed to be a plus. Okay? For whatever reason, we've got a big shortage of lithium, and that's a whole different thing, but there's never figured out yet why lithium is so rare on the earth when it's number 3, but we need it for batteries, and there's not enough to go around. Okay, so just set your moles over your, this time we want our volume, sorry. And we know we want a 3.00 molar solution. So you need 3 significant figures here. How do you do this math? You are supposed to know that you're supposed to divide and what you're supposed to divide. The V comes up here, the 3 goes down here, and then you divide this by this. I will make sure I go out of the way to put one on there. The test the math is similar to this to make sure you know how to do 8th grade pre-algebra. 7th grade pre-algebra. So it's 4.171. This goes here, divided by 3, comes out to be 1.57. Something like that. Next one. 73. Nope, we're not doing 73. 75. Got a table there. Stock solutions of HCl with various molarities are frequently prepared. Complete table 7 by calculating the volume of concentrated or 12 molar hydrochloric acid that should be used to make a liter of hydrochloric salt solution with each molarity listed. So I have to do this particular thing several times a year. So there's our table. So we want the volumes, those 5 volumes. Now, molarity is moles per liter. If you bring this up and multiply, moles equals molarity times liters. And you can set moles equals to moles, or molarity times liters equal to molarity times liters. I have showed you this repeatedly. This is what your book calls the dilution equation. We'll do a very similar thing with acids and bases coming up. One side's the concentrated side, the other side's the dilute side. Do we have to do that calculation 5 times? So if I put 12 molar times V, this is my concentrated side. This side will look the same each time. The other side is the concentration in molarity times a liter. Apparently we need a liter each time. I'm going to check that and make sure that's what it says. 1 liter of HCl solution with each molarity listed. So the dilute one is going to be a liter every time. 1 liter. And on this side, our numbers are 0.51, 1.52, and 5. So this is the way it sets up. Let's just do the first one. 0.5 times 1 is 0.5. In this case, the unit would be moles. And divided by 12. Well, whatever that is, 0.5 divided by 12 is 0.0417 liters, or 41.7 milliliters, because this wants to know how many milliliters we need of the concentrated. So that will go here. On the next one, 1 times 1 divided by 12 would be a 12th. So it'd be a 0.04, no, that's not it. Okay, next, I'll show you what all the answers are. 1.5 times 1 divided by 12. 2 times 1 divided by 12. That's a sixth, which would be 16 or so percent. So that one would be about 8.08, about 8. And 12 divided into 5. You end up with 5/12. And so the answers come out to be 42 milliliters. The more concentrated we get it, it's 42, 83, 125, 167, and 417. I mean, this, if this is 41.7, this is going to be about double. This is going to be about another 41.7. This is going to be about double this one. And then we have 5. It'd be like this one plus that one. This one double plus that one. Okay, so that's how you do the dilution equation. Yes, you'll be asked about all of these on the test. And this is our review for that portion, so we are not going to go back and do that. 80. What is the molality of a solution that contains 75.3 grams of KCl dissolved in 95 grams of water? First, turn your grams of KCl into moles. And 75 grams of KCl is about a mole, so we have about a mole of KCl. And so the molality is 1 mole over 0.095 kilograms of water, and it comes out to be 10.5 molar. Because 95 milliliters is 95 grams, and 95 grams is 0.095 kilograms. Okay, let's keep going. 82. What is the molality? Again, it's moles per kilograms solute. Make sure you're using that. What is the molality of a solution containing 30 grams of naphthalene dissolved in 500 grams of toluene? So convert naphthalene to moles and then divide. So 30 grams of C10H8. If you have 10 carbons, that's 120 plus 8 is 128. Divide that, your number of moles is 0.234. Divide 0.234 by 0.500 kilograms of toluene, and the molality comes out to be 0.468 molal. And we have a couple more. What are the 3 ways to increase the rate of solvation? We did a lab on this, so you know that one. We've done this lab twice, counting last year. You can increase the rate by increasing the temperature of the solvent, increasing the surface area of the solvent by grinding it up into little pieces. We did this with the sugar, I think, last week. and stirring or agitating or shaking or some other way. Next one. 89. At a pressure of 1 atmosphere, the solubility of a gas is 0.54 grams per liter. Calculate the solubility when the pressure doubled. This is Henry's law. Solubility is proportional to pressure. So all I have to do is put 0.54 grams per liter as the solubility over 1.5 atmospheres. Double the pressure, should double that, cross multiply, divide. You know how to do that. Should know how to do that. And it comes out to 1.08. All you gotta do is double that number. And then we have a graph, I think. I think this is number 91. There's the graph in the book. Compare the solubility of potassium bromate and potassium nitrate at 80. Potassium bromate, here we are at 80. Potassium bromide, potassium nitrate. This one is about double. Okay, so the solubility of KBr is 95 grams per 100 grams of water. Now you might not be able to read 95 off of there. You might come up with a different number, but there's 80, there's 100, 90 is right between, 3/4 or so of the way there. 95, solubility of KNO3 is about twice as high. It's not quite 180 at almost 179 grams per 100 grams of water. You might not have these exact numbers, but you'll be in the ballpark. So I think that's all of them that were assigned. Yes, so there you go. Turn this in. You should have this in to me before class on Wednesday.